We're back with our second learning target of 0.3, which is I can graph linear inequalities by hand. So we just got done graphing equations. Now inequalities are much like that. So we do the same thing where we plot the y-intercept, we count the slope. But with inequalities, we can't just go ahead and draw a line. We have to determine whether the line should be a solid line or a dashed line. And then after we've done that, we have to shade the graph in the appropriate direction. Much like when we were solving inequalities, and we would have to determine whether we would plot an open circle or a closed circle and in which direction we would shade. Now I have a table down here that might help you decipher these things. First of all, we have 4 cases. We could have greater than or equal to, less than or equal to. Now, if you have greater than, that means that the values we are talking about are greater than the line that we are drawing. So in that case, we shade above the line that we graphed. If we have less than or equal to, that means the values are less than, we shade below the line, okay? Now, when we determine what type of line to draw, whether it's gonna be solid or dashed, that's when we look at whether it's just plain greater than or less than, or whether it has the or equal to on it. If we have the or equal to symbol on it, that's a solid line. That means we can include the values on that line. If we don't, if it's just greater than or less than, that line is dashed. Whoops, wrong one. Dashed, okay? We cannot include those values on that line. All right, and I have one more note down here for us. As we learned in our first learning target, we have vertical lines that don't necessarily follow all the rules that other lines do, and this is the same because we can't shade above or below a vertical line. We are going to shade to the right for greater than and to the left for less than. Okay, let's do our first example. Graph each linear inequality. 3x is less than 4 minus 2y. Now, just as we do when we are graphing equations, we need to write this in slope-intercept form. I like to have my y's on the left side, so I'm actually going to bring over this 2y to begin with. I'm going to add 2y to both sides, and that gives me 3x plus 2y is less than 4. Okay. Now I want to solve for y. I'm going to get rid of this 3x, subtract 3x on both sides. So now I have 2y is less than negative 3x plus 4. And finally, divide every term by 2. So y is less than negative 3 halves x plus 2. And now we have our inequality in slope-intercept form. So we are going to plot our points and draw our line to begin with. We have a y-intercept of positive 2, slope of negative 3 halves. So we're going to go down 3, right 2. Down 3, right 2. Our symbol is less than. That means we will draw a dashed line because we cannot be equal to that line through our points, and because it's less than, we shade below, so that means down, and that is correctly graphed. Looking at letter B, we have a special case because it's just y is greater than or equal to negative 1. If you remember, this is how we write horizontal lines. You don't have an x in there, which means the slope is 0. Greater than or equal to means we're going to have a solid line. So I'm just going to have a solid line at negative 1, the y value of negative 1. And I'm greater than that, so that means you shade above. So every y value either on this line or above it is greater than or equal to -1. Moving on to letter C. We're back to an inequality that's in standard form that we need to rewrite in slope-intercept form. So I'm first going to subtract 5x from both sides. That leaves me with 10y is greater than -5x plus 20. Then I'm going to divide everything by 10. And that leaves me y is greater than -1/2, because I'm going to reduce that fraction, 5 over 10, x plus 2. All right, so plot my y-intercept of +2. My slope is -1/2. That's down 1 over 2. And heck, I'm going to go the other way as well, up 1 over 2, just so I can draw a nice line. Since this is just plain greater than, this is going to be a dashed line. Greater than means shade above. In our last example, x is less than 4. Remember, when we have x in the equation, that means vertical line. And less than, just plain less than, means that it's going to be a dashed line. So I'm going to put a dashed line, vertical line at the x value of 4. Less than means I will shade to the left of this line. Anything over here has an x value that is less than 4. And we are done.